Hello and welcome. Today I would like to discuss a unique method for balancing chemical equations. As we know, not all chemical equations can be balanced using traditional methods. Some reactions can be quite complex, making it difficult to find a simple solution. Fortunately, there are alternative methods available to ensure balance in these cases. Today, we will focus on the electron balance method for balancing redox reactions. This method allows us to quickly and efficiently balance the equation. The process involves several steps, which I have detailed on the left side for reference. To illustrate, let's consider a specific example. Given the following chemical equation, there should now be a chemical equation given. In order to balance this equation, we will employ the electron balance method. By following the steps provided, we can easily determine the coefficients necessary to achieve balance. Remember, balancing complex reactions is not always easy, but with the help of methods like the electron balance technique, we can successfully equate reactions that may have seemed impossible before. Please let me know if you have any questions or require further clarification. Cuprum plus ammonia NH3. You get copper, nitrogen, and water is released. So, I have done the first step, written down the equation which is not equated yet, and in this connection we need to do the second part of this step, namely to put the oxidation degree of each element in the proposed scheme. So in cuprum O we start with oxygen -2 and hence copper has +2. In NH3 we remember that this is a special molecule. Here nitrogen is -3 and hydrogen is +1. Simple substances, copper 0, nitrogen 0, and in water, hydrogen +1. The rule of the cross works. So the first stage we have done, put the degree of oxidation in the not yet equated, in this record not yet equated reaction scheme. Okay, now we need to determine which elements have switched charges. We can see that it's copper. Let's underline it on the left and right. And it's nitrogen that changes its oxidation degree. Let's underline it on the left and on the right. Now we need to perform the following procedure to find out what processes are taking place. To do this, we make two half reactions. The first half reaction will deal with copper. The cuprum from +2 goes to charge cuprum 0. What happens for copper? For copper, the oxidation degree goes down. When the oxidation degree goes down, that means the element has to accept electrons. And the difference between the numbers +2 and 0 is just encapsulated in the number 2, which means it's going to accept 2 electrons. Now, the second element that changes is nitrogen. It's gone from -3 to nitrogen with a charge of 0. But now let's see, nitrogen has an index 2. This index is always present in these simple substances. I will remind you there are several such molecules, and nitrogen belongs to such molecules which are always written simple substances with the number 2, with the index 2. Then I have to take that 2 into account, put it here, and here too. But then for nitrogen, the oxidation degree goes up for nitrogen, which means that it has to give up electrons in this bond. If it were 1, it would give up 3 electrons. And since there are 2 here, it turns out it will give up 6 electrons. Record this on the right-hand side, showing +6. So the processes are gotten as follows. For copper, there is an acceptance of electrons, and for nitrogen, there is a giving up of electrons. But they write it down with just these two half reactions. Now next, let's take the numbers we've found beyond lines 2 and 6. Then we'll swap them around to equalize the number of electrons being given up and the number of electrons being accepted. But as we can see, both numbers are reduced by 2. Then we'll shorten it and we'll have 3 and 1. Let us then recall what such processes are called. The elements that accept electrons, and this process it's called reduction. And the element that's involved here, it's called oxidation, which means I'll make a short note here. It is an oxidizer. So now what will nitrogen be? Nitrogen will be, it's an oxidizing process, and it's called a reducing agent. And so it is called, and let's write this down briefly, exactly that. Now we must perform the next step to balance the number of atoms of each element. To do this, let us put the numbers we have found. 3. First of all, when the obtained coefficients are arranged, and these are called basic coefficients, put them to the zero charge if it is present. If there is none, then to the smallest by the negative oxidation degree, or the smallest among the mathematical value. So a 3 would go here. And let's also put a unit. And although usually the unit is not written, but at first, in my opinion, it is very important to put it and find out when and in what cases it will be put, this unit. In the future, of course, it is not necessary to write it down. So copper on the left side is 1, on the right side is 3, so before cuprum O we put 3. Nitrogen on the left side is 1, on the right side is 2, so 2KNH3. Now check the hydrogen on the left side. We have 2 by 3, 6. Here we have 2, and then to the water formula we put 3. And usually in these reactions you check for oxygen. Oxygen on the left side is 3, and on the right side is also 3. That's it. We have completed all the steps. This procedure is called electron balance. The electronic balance consists of these steps. The last equation, which contains the accurate coefficients, represents the final form of the record known as the electronic balance. This balance utilizes the oxidation degree and serves as a method for equalizing these specific interactions. I hope this concept is clear, and in our upcoming lessons we will practice these examples to learn how to proceed from simple to more complex scenarios. I trust that this explanation has been understandable. Farewell.